Another day, another Maker Advent, and today we have three things. We also have banana for scale. Hello again, old friend. Three things. They're all the same thing though. I got three ESP32 C3 Super Minis, there's a mouthful, for just about £6 something the other month. The start of November, in fact, when I buy all of my tat from Temu for Maker Advent. I mean, all my quality gear, not tat. There it is. That's one of them. And just for completeness, there's the other two. These are super tiny ESP32s. Banana for scale is touching. It's literally the point of banana for scale. Let's get the camera in shot and get it in focus. Come on, there you go. Super tiny, a few GPIO pins, but it is a full ESP32 C3 on a really tiny board. It's also got really good deep sleep power saving. So you can use it and leave it somewhere and it just sips away on the power. I've flashed onto this MicroPython and I'm going to show you just quickly how it all works. But first I'll show you the TeamU listing. Boop, there you go. Look at that. I'm all in OBS at the minute because I've been testing some stuff for OBS for a tutorial at work and I'm getting into it. Anyway, they're now £8.30 for three, which still isn't a bad price. Would I use these in a professional project for a client? No. I would buy something from a local reseller like Adafruit, Pimoroni, the Pi Hut, that sort of thing. That way you've got if you've got a problem, you've got recourse with them. Buying stuff like this off Temu is cheap and cheerful for hobbyists that like to play around. No problem whatsoever. Go for it. But for proper business work, pay the extra money, get the proper stuff. So one thing I want to mention before we get too far into this is some thanks. So randomnerdtutorials.com. I'll put a link down in the description. Hey, I'm a YouTuber. I got it right this time. Absolutely fantastic resources. Absolute treasure trove of knowledge in here. So randomnerdtutorials.com. I'll put a link to this specific page and their website in general. Have a look. Absolutely great. On to the hack. I have got MicroPython installed on my test board. Here, there we go. You see it's on, it's connected. I'm going to swap over to the MicroPython section. Yeah, there we go. Right, I have got the standard test script. The absolute standard. So it's a blinky. The simple stuff. From machine import pin, so we can use GPIO. Import time, so we can control the pace at how often the LED flashes. We've got the LED itself, so we've got an object, a variable called LED, and we're saying that the LED is on pin 8 and it's an output. We then use a while true loop to make it run forever. And then to turn the blue LED on, which isn't lit at the moment, as you can see, we have inverse logic or reverse logic. So we've got to turn the LED pin off for it to turn on. So that's why we set LED value 0. I then do print LED on. That's a visual debug. So if I can't see the LED flashing, but the print LED comes on, it means that the code is working, so I can see it. And it means I've probably got the pin number wrong or I've cocked up the logic. Time sleep for a second. And then we repeat the same as before, but changing the LED value to 1 to turn the LED off, then print LED off, and then sleep for a second. So if I just run this now, you will see LED on, LED off. And you'll see the LED light up. There we go. Nice one. So we've proven that MicroPython works on ESP32 C3 Super Mini. That's a mouthful. And now you're thinking, Les, ESP32s are all about the Wi-Fi, mate. Give me Wi-Fi. I want to go on the internet. Okay, let's do it. I've got a second example. This is taken from the MicroPython examples page. I've just tweaked it a little bit. I've got an external secrets file for this, so I'll go for it line by line. Import network, so we can go on the internet, make network connections. From time import sleep, yeah, just so we can control the pace. From secrets import star. Secrets is my own file written to the ESP32 C3 Super Mini that contains the SSID and the password for my Wi-Fi. Obviously, I'm not going to show that online. We get an object called WLAN, which is the Wi-Fi network connection, how we make a connection to the chip on board. We then turn that chip on. We then do a customary scan for Wi-Fi. I then say, okay, connect to my SSID and pass. Those are two variables inside the file called secrets, which we've imported. I then sleep for 5 seconds, which isn't really necessary. You can just have it where it just goes connect and then goes to the next line, is it connected? I put a sleep of 5 seconds in because I get better results or better chance of success by introducing a small sleep. And 5 seconds seems to be about right. And we can wait 5 seconds. WLAN is connected. That's a check that says, okay, call this function. Are we connected to the Wi-Fi? Are we on the internet? Yes or no? And then it will print the IP address of my ESP32 in the old IPv4. So I'm going to stop any code running and I'm going to click on play and we should see it go through. Now it's going to do a soft reboot and it's going to wait about 5 seconds and then we'll see my IP address on the network. There we go. 192.168.0.171. Subnet mask of all 255 and a 0. Proving that this ESP32 can get on my network. And if I were to import something like requests, I could do some whiz-bang stuff with the internet, which is what I'm going to do. So that's it for today. We've proven that this works. We can make stuff blink. We can go on the internet. The next step is to do something with that. So we're going to have it do some whiz-bang stuff on the internet that I haven't thought of yet. I'll think about it today. That's all for now. I'll see you later. Ta-da.